Today we're going to be looking at finding limits using L'Hopital's rule. It's not L'Hopital. The H is silent. L'Hopital. So if you're trying to find a limit and it's got this form of a rational function with f of x in the numerator, g of x the denominator, and you plug this number c in, or c could be infinity, and you get that f of c over g of c is an indeterminate form, so 0 over 0, infinity over infinity, then you can take this limit by taking the limit of the derivatives in that rational form. So let's just put it to work on an example. Let's get straight into it. So if I plug 2 into what we've got here for x, then I'm going to have 4 minus 4 in the numerator and 2 minus 2 in the denominator. So that's an indeterminate form. So I can use L'Hopital rule. And so it's going to be the limit as x approaches 2, and the numerator is going to be the derivative of the numerator, and the derivative of x squared is 2x. The derivative of minus 4 is 0, and the derivative of x minus 2 is just going to be 1. And so now I'm just going to plug 2 into that, and my answer is 4. Okay. Now, yes, we could have solved this by factoring. All right. We certainly could have solved this by factoring, because the numerator does factor to x minus 2 times x plus 2. And so I can cancel the x minus 2's because x is approaching 2. It's not equal to 2. If it were equal to 2, I couldn't cancel because I'd have 0 over 0. So I'm just saying that I could have also solved it this way and gotten the same answer, but this is using L'Hopital's. Okay. All right, so let's move on. Let's look at him. Okay. So as x approaches infinity, that's going to go to infinity over infinity. Once again, an indeterminate form, so I'm going to use L'Hopital's, and this will be the limit as x approaches infinity of the derivative of ln of x, which is 1 over x, all over the derivative of x, and 1 over x over 1 is just 1 over x. And so that's going to head off to 1 over infinity, which is 0. So my answer is 0. All right, let's keep going. Okay, what about this guy? If I plug infinity in for x, I'm going to get that, which is going to be infinity over infinity. So that is an indeterminate form. So I'm going to use L'Hopital's. And the derivative of e to the x is just e to the x. And the derivative of x cubed is 3x squared. Now, as that goes to infinity, I'm still getting infinity over infinity. It's still an indeterminate form. So what do? You apply L'Hopital's again. Apply it a second time. So I'm now going to take the derivative of this. The derivative of e to the x is e to the x. The derivative of 3x squared is going to be 3 times 2x to the first. Again, that's going to tend to infinity over infinity, so I apply L'Hopital's again. And I'm going to take the derivative of that. The derivative of e to the x is e to the x. And the derivative of 6x is going to be 6. And now what's going to happen is That's the same thing as that. So that 1/6 can come out the front. And so it's going to be 1/6 times e to the infinity is going to be what it trends to, which is going to be trending to infinity. So the answer to that one is infinity. And finally, let's come down here. All right, how am I going to get that one? Okay, if I plug in x is equal to 0, cosine of 0 is 1, and 0 squared is 0. So this is an indeterminate form, so I can use L'Hopital's. So the derivative of the numerator, the derivative of 1 is 0. And then the derivative of cosine of x is minus sine x. And then the derivative of the denominator is going to be 2x. So now I'm just simplifying. Those two negative signs will cancel. And now if I plug in 0, I'm going to get sine of 0 over 2 times 0, which again is 0 over 0, which again is an indeterminate form. So I'm going to apply L'Hopital's again to that. So I'm going to have the derivative of sine x is cosine x, and the derivative of 2x is 2. And if I plug in 0, I'm going to have 1/2, and that's my answer. Okay, so I think that's all I've got for you. So I hope this video helped you, and I'll see you on the next video. Thanks for watching.